So, yesterday you did an investigation on slope. Learning about how steep something is or how not steep something is. I like to think about slope like my treadmill. Okay? Now, obviously, like your treadmill, you start off going like this, right? Straight. But you can increase the level so that you're like going uphill, right? Because of the fact that it's on a floor, you can't really go downhill very much unless you turned around and walked this way. Then you could be walking downhill, right? If you are going completely flat, no incline or decline, I'm trying to get that as flat as possible on the screen. If you're going completely straight, not uphill, not downhill, just completely flat, that's a slope of 0. No incline, no decline, that's a slope of 0. The one place your treadmill cannot physically work is there, right? Your treadmill can't go vertical. You're going to need climbing equipment if you're going to try and run that way. That is what we call an undefined slope. Now, in the activity yesterday, I think they called it an infinite slope. I'm not familiar with the term infinite with regards to slope. The more accurate term would be undefined. Okay, so we're going to use the term undefined for that slope. All right, so we are going to focus. These first 3 questions are very similar to what was on last night's homework, right? We're going to identify the rise and the run. Rise over run is what's going to give us our slope. Okay? Let's see. Rise. What direction does rise go? Up or down? In other words, it's a y direction. You're following the y-axis up or the y-axis down. Run, then, is a left to right movement. You're following the x-axis, left or right. So, I'm going to pick 2 points. They gave me 2 points. That makes life easy. If I have to pick 2 points, I want 2 points that are exactly where grid lines cross. Exactly. Not close, but exactly. From here, by the way, just to be clear, when we read a graph, we always read a graph from left to right. Just like you do in a book, always start on the left and move to the right. Is the person that's standing right where my finger is, are they walking uphill or downhill?
Uphill.
Uphill. That means my rise is positive. If they're walking downhill from left to right, my rise is negative. So, uphill, my rise, how far up do we have to go to get to the next point? 4? That means my rise is a positive 4. Then we turn, and how far do we have to run?
5.
5? So what's my slope?
4 over 5.
Boom. Yep. All right, this one is my little person from left to right going uphill or downhill?
Downhill.
Downhill. Which means my rise is what?
Negative.
Negative. So my rise is going to be negative what? 1, 2, 3, 4, 5, 6. I'm going to the next point that's marked. And then my run is 1, 2, 3. Your run, you're always going to keep positive. It's your rise you want to keep negative or positive. So let's see. My slope is going to be negative 6 over 3. What does that reduce to?
1/2.
Negative 2. That's what I want to see as your slope. Okay. All right. What about here? Uphill or downhill?
Uphill.
What does that mean about my rise?
It's going to be positive.
Positive. How far are we rising? 1, 2, 3. And how far are we running?
4.
4. So what's my slope?
3 over 4.
Getting the idea? That should be a review from last night. Okay? Now these two actually have situations on the y-axis and the x-axis. Do you see that? First thing I want to do is find the slope. So again, rise over run. Now I need to see, as I'm counting my rise over my run, are we counting by ones in both directions? So in my x values, each line is representing 1 because they're going 1, 2, 3, 4, 5, 6. So I can count the x values as 1. Are they counting by ones this way? Look carefully. Yes, they're counting by 2s, but they're counting every other line. So each line does represent 1. I just didn't write all those values. Does that make sense? So I am counting the exact same way I'm counting up here. So let's see, my rise is going to be what? 1, 2, 3, 4, 5, 6. And my run is what?
4.
4. So what's my slope? 3 over 2. You always have to reduce. Always, 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 always. There's never a circumstance ever where I don't want you to reduce a fraction. Okay? So what does this mean? Well, 3 was an up and down movement, correct?
Yeah.
Well, technically it was 6, but it was an up and down measurement. So 3 has to do with my salary, right? Because that's what the up and down axis is. The 2 was a side-to-side movement, and that is years of service. So what is this graph telling me?
That salary changes every 2 years.
The longer you work, the more you get paid,
Just
right? Which should work out that way, right? Makes sense. The longer you're with a company, the more experience you have. Hopefully, the better at your job you are, all that kind of stuff. Based on the slope, we can say specifically that every 2 years, my salary, and it looks like it says dollars per hour, increases by $3 an hour. So if I start working there tomorrow and I get $10 an hour, then in 2 years, I will be making $13 an hour. Every 2 years, by the time 2 years hits, my pay has gone up $3 an hour. Yes, ma'am.
I have a question for like related.
Mm-hmm.
Do you start with any point, or does it have to be 1 point?
You always want to work left to right. So you can use any point. I used the points that were given to me in the problem. You know, they have the coordinates written. It doesn't matter what 2 points you pick. You wouldn't want to pick something like right here because it's not crossing at grid lines. You would want to pick something that's crossing exactly at grid lines. Now this one's a little tricky, but here you could have picked this point. You could have picked this point. Any one of those you could have done. But always start with your left to right.
Like the point that they are given, so like you can like enter one, like from the top one or the bottom one.
Here,
Yeah.
which point's further to the left? This one. So work from that one to that one. This one's further to the left, so work from here to here. Always start with the point that's furthest to the left. Okay? Just like you read in a book, you read from left to right, we read a graph from left to right also. Okay? All right. Next one, hurricane evacuation. Oop. Notice this one is decreasing instead of increasing. Why is it decreasing? Well, these are the people remaining. So as people are evacuating, there are less and less people remaining. Makes sense, right? Like people evacuating when the bell rings at 2:55 for the end of the school day. The more time that has gone by, the fewer people there are remaining on campus, right? Same kind of idea. Are we counting on by ones in the x direction? Yes. Are we counting by ones in the y direction? No. So my rise I have to be careful with. My rise, it looks like it's only going 2, doesn't it? Technically it's going negative. But it's really going from 1,200 to 800. So how far is it going? 400. And what's my run? 3. So that's my slope. What does that mean?
For
Every 3 hours. What? 400 people evacuate? So in 3 hours, they evacuate 400 people. You could also say something like, every 3 hours, there are 400 less people remaining, if you want to use the terms they use there. Kind of make sense? Okay. How many people were there to start off with? How much? 1,600, right? Because that's at time 0. So that's at the beginning, right? Before they started charting the time. Okay. Where would I look for if I wanted to know what time it is when all the people are gone? Wouldn't I follow this out and want to see where does it hit the x-axis? That would tell me how long it is until everyone's evacuated. Okay? All right. Next thing I need to show you. By the way, my last period class, they had a fit that number 9 was skipped. Sorry if that bothers you. You're just going to have to deal with it. On your homework, it's set up the exact same way, and guess what? They skipped number 9 too. So apparently we have something against number 9 today. So your homework is just like this, but then there's a second page also that has some more find the slope on it. Okay? So find the rate of change or slope. Rate of change is another term for slope. Did you know that?
Yeah.
It's another term for slope. Also, slope, I'll get to that later. When I have 2 points, there's a little formula we use to find the slope. I see you have heard this before. y2 minus y1 over x2 minus x1. Okay? We use that anytime we have 2 points. It doesn't matter which point I call y2 and y1, or y2 or y1. It doesn't matter. I'm going to get the same answer regardless of which direction I go. What I need to remember about this is if I choose to do 33 minus 5 and I put this y value first on top, I have to put this x value first on the bottom. And if I chose to put this 5 on top first, I would have to put the 4 on bottom first. I have to stay consistent with the direction I'm going. So 33 minus 5 over 11 minus 4. What's 33 minus 5?
28.
What's 11 minus 4?
7.
And 28 over 7 is 4. So that slope is 4. Is there another way I could find the slope between 2 points? I could go to a graph, plot the 2 points, and count my rise over my run. But how many people enjoy going to the graph for that? Usually they would rather just do this. Okay? All right, so this guy, if I did 9 minus 8, what would my bottom have to look like? 3 minus 4. I cannot do 4 minus 3. I have to keep it in the same order. 9 minus 8 is 1. 3 minus 4 is, and what's 1 over negative 1? Just to prove my point, if you go the opposite way, if you do 8 minus 9 and 4 minus 3, what's 8 minus 9? Negative 1. 4 minus 3, and negative 1 over 1 is still negative 1. The difference just is where your negative sign is. So it doesn't matter which point you put first, as long as you remain that consistent of, if I use this point first for y, I have to use this point first for x. Okay, you try the slope over here in number 8. Did you get negative 5 over 3? Or 5 over negative 3 if you went to the other side. Doesn't really matter. So. Now, obviously, we're going to skip number 9 because it doesn't exist. And jump down to these guys. Did I move too fast? Sorry. And the last thing we We need to find the rate of change or the slope from the table. Okay? So if I have a table, I really just have a collection of points, don't I?
Yeah.
So I can pick any 2 points from the table, and I can do what I just did up here. Yeah?
Yeah.
Or I could do it a little easier. Rather than thinking the y2 minus y1, can't I just do like this minus this, and this minus this? Because isn't that y2 minus y1 and x2 minus x1? It's the same thing, right? I could list the points if I want to. If that makes more sense, then by all means do it. And then do it the way you did there. Or you could just do -4. Now be careful. Minus -3. You need the minus sign and that negative sign. Okay? And then on the other side, I would have 4 minus 2. What does -4 minus -3 turn into?
-4 plus 3.
-4 plus 3, which is what?
-1.
And then 4 minus 2?
That's 2.
And -1/2 doesn't reduce, so that's my answer. So? Okay. What if I chose those 2 points? Question?
I was gonna ask, for number 10,
Mm-hmm.
is it okay if you don't do like the 2 bottom points?
Yeah, you can just go straight from here to here. That's fine. I'm going to do that on this one. So here I would do -8 minus -6 on top. What would the bottom look like? -4 minus -3, right? So this minus this, and then this minus this. What happens with this whole minus and negative thing? Becomes a plus. -8 plus 6 is -2. And this is going to become a plus also, so -4 plus 3 is what? And -2 over -1 is +2. All right, you find the slope of the last one. I'm going to use 2 points in the middle just to be a pain. And I'm going to go forwards. Ooh, really mess with you here. So 15 minus 20 over 6 minus 8. If you went a different direction, we should still end up with the same answer. 15 minus 20 is -5. 6 minus 8 is -2. What's -5 over -2? Is that what you got?
Yeah.
Even if you chose different points or went in a different order, you should still have gotten 5 over 2. Okay? So? All right, homework is on Google Classroom. Happy studying.